Hi, and welcome to a presentation of do single-sex STEM programs have merit, and if so, for whom, on what measures? So briefly about myself, I was born in Tokyo and I grew up along the East Coast. I have a bachelor's in physical chemistry, and I was a physics, math, and writing teacher in North Carolina for 5 years. I got a master's in education at Harvard University, and I'm currently an edtech developer, video game programmer, and researcher. So single-sex STEM education. While some organizations and advocates have called for specific programs that benefit historically underprivileged, disadvantaged groups in STEM, such as girls, others cast doubt on the entire idea and also mount legal attacks saying that they're discriminatory against men. So my research question was single-sex STEM education, which here is defined as attending a single-sex STEM program, which is extracurricular and out-of-school programs. Is there a main effect, and is this effect dependent on student gender? Is there an interaction on outcomes such as STEM subject interest, STEM-related identity, and STEM career intention? So past studies on this subject of whether or not single-sex STEM programs work have been mixed in effect and limited in scope. Social environments are generally thought to affect gendered aspects of identity, especially in adolescence. So STEM subjects, since they're stereotyped as male, especially when it comes to as a career choice, ideas of fit might influence career choice more than achievement. So girls who are good at STEM may nonetheless still choose to not choose as a career because they might feel like they might not belong. So single-sex STEM education might influence this dynamic because they might shield students from gender discrimination and stereotype threat. Basically, if you put girls in an environment where they don't have to compete with boys, or the teacher doesn't have as much of an opportunity to discriminate by gender, then girls are free to nurture their STEM abilities and identity more. But there's also a counter-argument that says sex segregation might strengthen perception of difference and thus stereotypes. So if you're separating boys and girls every time there's a science class, aren't you sending the message that there is a difference in how the two genders approach STEM? So our sample was a nationally representative survey of 15,000 US undergraduates from the fall of 2017. They were all taking an introductory level English courses. We did multiple regression analyses of STEM interest indicators, the interest, identity, and career intention that we mentioned before. Our sample, a small sliver had attended some single-sex STEM program. Majority had only attended co-ed programs, and some fraction had attended no STEM program whatsoever. The sample was majority female, although not by much, and the sample was majority white, with Asian and Black being big slices of the remaining. So subject interest was operationalized from their answer to, at the end of high school, how interested were you in science, mathematics, engineering, and computing? They would bubble in their answer between not at all and extremely interested, and we would take the highest interest as their STEM subject interest overall. STEM identity, there were a bunch of statements relating to self-efficacy, self-concept, also how other people identify them as a STEM person, also feelings of belongingness. Turns out that the 17 statements, most of the variants loaded onto one factor, and so we simplified that as STEM identity. And STEM career intention, for these 9 careers, we asked, are you interested in this career? Yes or no, and this is at the beginning of first semester college. Our results of the models were as follows. We'll go over the graphical representations of these later, but I do want to point out the yellow part here that we did actually control for whether or not they were interested in a STEM career at the start of middle school. So career intention is taking into account how interested they were before they began their middle and high school activities, and we also, in that time period, controlled for the number of STEM-related activities that people engaged in often, because we recognize that the variance there may not necessarily be captured by other things like socioeconomic status and other demographic controls. So STEM subject interest at the end of high school. All these graphical representations will follow the same format. We have the STEM programs attended on the bottom. Left-hand side is none, middle is only co-ed programs, and then right-hand side is if they attended at least one single-sex program. and all our graphs, they're separated by boys and girls because we want to look for the gender-dependent interaction. So for STEM subject interest, which is a z-scale parameter, standardized, we start off with a baseline. So people who attend no STEM programs whatsoever, there is a gender gap in subject interest. Boys are much more likely to express interest than girls. But also, for those who attend co-ed programs, it seems that they express a higher interest than their gender counterpart who attend no STEM programs. But the gender gap still remains because basically these two genders between the two groups, the difference is basically the same. So the slopes here are basically parallel. The difference is there's no significant interaction with gender. But when it comes to students who attend at least one single-sex program, the picture is a little bit different. So the boys actually, it seems that there's no significant difference between boys who attend co-ed programs and boys who attend at least one all-boys program. But for the girls, there is a pretty marked difference in subject interest. The girls who attend at least all one girls program, STEM program, they are much more likely. They're likely to express a significantly higher interest level than girls who attend only co-ed programs. STEM identity, for feelings of belongingness and self-concept, the trend is basically the same. Among boys, it doesn't seem to matter what type of STEM program they attend, as long as they attend something. And if they attend some STEM program, they generally tend to express a higher level of STEM identity than attending none. But for the girls, there's a pretty clear gradient where attending only co-ed programs, STEM programs, the girls, as a result, are likely to express a higher level of STEM identity than girls who attend none. But attending at least one all-girls STEM program makes it likely that girls in that group express an even higher STEM interest that even catches up to the boys. So STEM career intention actually has a different picture. The baseline here is basically the same. So there's a gender gap, and this is likelihood of expressing STEM career intention. This one's a logistic model. For only co-ed programs attended, for the boys, if they attend only co-ed STEM programs as opposed to attending none, they're much more likely to express interest in a STEM career. But for the girls, there's actually no significant difference. And keep in mind that these girls in the co-ed here are the same girls who had expressed higher interest and higher identity according to our two previous outcomes. So it's the case that just having higher interest and higher identity doesn't necessarily equate to a higher likelihood of wanting to go into a career. But then the people who attend at least one single-sex STEM program, the picture is even more complicated, because it seems like the boys who attend at least all one boys STEM program are no more likely to express interest in a STEM career than boys who attend nothing at all. But for the girls, that missing boost in career intention that we expected for co-ed STEM programs suddenly shows up. Girls who attend one all-girls program is so much more likely to express STEM career interest and even catches up or expresses interest in a STEM career at the same likelihood as boys who attend co-ed STEM programs. So two questions arise. Why are all-girls STEM programs associated with uniquely higher STEM affect outcomes? And why are all-boys STEM programs not associated with STEM affect expected from general STEM attendance? So it could be that the program content is different. In all-girls STEM programs, there might be more explicit assistance in building career intention. It might be that there's psychological safety for girls in all-girls programs, that there is no counterpart or analog for the boys because boys don't face as much stereotype threat when it comes to STEM. It could be that all boys programs are not conducive to effective long-term STEM affect gains. So basically maybe they just there's too much goofing off. It could be that maybe girls in co-ed programs get sick of boys and avoid STEM careers to avoid working with boys unless they have that one inoculating experience of an all-girls STEM program. Or more seriousseriously, it might be that all boys STEM programs basically have a very different mission from other STEM programs. It might be that there's more of a religious focus, or it might be an inner city program that maybe the focus isn't the same as other typically enrichment STEM programs. So for conclusions, one, there is a significant interaction effect for single-sex STEM programs with gender. Two, STEM program attendance of both types is associated with greater STEM-related affective measures compared to attending none. Three, higher STEM subject interest and identity do not necessarily equate to higher likelihood of STEM career intention. Four, all-girls STEM programs are associated with significantly higher STEM affect outcomes compared to both co-ed and no programs. And all boys STEM programs are oddly not associated with higher career intention as we might expect. So based on these, we have a couple of recommendations for both the programs themselves and future research in the field. For the programs, we would vouch for their continued existence, especially the all-girls STEM programs. Clearly, they provide a unique benefit to girls' STEM affect that is not seen in co-ed programs, and expanded access to those same programs, because currently the programs are still very rare. For future research, we would advocate for more qualitative studies of program content and methods, because our study can't speak to what in particular these programs do program-wise that actually makes them effective at building identity and career intention, and more quantitative use of long-term career interest to evaluate program impact. If we had just looked at identity in interest, subject interest, we would have missed the perplexing trend that we saw in career intention. We'd like to acknowledge the non-presenting co-authors, Chen, Gerhard, and Philip, for their mentorship and collaboration, National Science Foundation grants for supporting this work, and Dr. Jacqueline Doyle, Sipokazi Carbo, and Annie Medina for their input in the research process. Thank you for your attention.